So, the original idea of this was to answer your questions. So, do you have any questions?
I have a question about this intersection plane.
Mm-hmm.
How can you put it to the lighting?
Okay, so with Geographer 5, you can have 3D graphics, and after a while you learn to do the Control-Shift-3 thing, but for purposes of showing, I'll be clear here. Normally, when you get this window, it's free floating like that, but you can, as with any window, you can dock it into the main window and drag it around to wherever you want it. I normally have it here, but that's a matter of choice. There are various settings to go with the 3D window. For instance, you can have a small box, or a medium box, or a large box. And if you click it, the actual box doesn't show. So I normally have a large box which doesn't show. To rotate it, you can either rotate it like this automatically, but you can also rotate it manually by right-clicking and dragging, and that gives you complete control. If you're into 3D glasses, you can put them on and have everything shown in 3D with two colors. And if you want to view it from a particular direction, there are various options to do that. But that's the normal view. Okay, so you ask about intersection of planes. So for instance, if we have a cone, okay, so when we make a 3D object, when we're in the 3D window, we can actually select new tools, like for instance cone, but we can also extrude to pyramidal cone, and that works like this. You create a circle, and we can create the circle in the ordinary XY plane, and it will then be visible in both, because the 3D view is just a copy of the ordinary graphics window, or rather the graphics window is the XY plane of the 3D graphics. We can then extrude this to a cone by clicking on it and saying I want it to be, let's say, 6 high. That's one way of making it. Okay, so then we have a plane. You can make planes in different ways. I'm going to do it now by putting some points, because I can then drag the point and move the plane. So I will click twice there. That will actually put the points in the XY plane. They are somewhere down there. It's D. Let's see, up there. Okay. The third one I want to have somewhere up here. So if I click again, but if I try to drag it, it will now only move in the XY plane. To move it vertically, you click on the point once and change the mode, and you then drag it only vertically. Okay. You could also put a point in by giving 3D coordinates if you want to, like 2, 3, before. We'll create a point somewhere. And I will now make the plane. Plane from 3 points. Oops. Oh, I might. That. And that will intersect it. It's normally quite difficult to see what's happening unless you actually rotate and see what's happening, because you get a mental image which integrates all the visual cues that you get. So you normally need to rotate it around a little bit to see what's happening. To see the intersection curve, there's a tool called intersect two surfaces. Now it doesn't work with anything. It works with like cones and planes and conics and stuff like that, but not too many things. It's also can be difficult to select things. In this case it's not difficult, but if you have a polyhedron like a cube, it's almost impossible to click on the cube because you keep clicking on the surfaces of the cube. So then you need to select things from the algebra window, like cone, plane, and that will create, you can now see that the intersection is actually a little ellipse, and there was a conic here created. And your question was, can I now view this plane as a window? And yes, you can. You just right-click the plane and say create a 2D view from this window A, and you get a new window. And it will show you the intersection, and since the cone actually stops there, this ellipse actually stops there. But if I move the plane, I can, well, maybe not. Maybe I have to move one of the other points as well. There, you get an ellipse. We can make it almost a circle. You don't get any axis here, because to do that you'd have to project the axis onto the plane somehow. But the axis don't actually go through this plane. But I can now use ordinary 2D tools in this window. I can measure angles, I can create polygons, etc. So I hope that was an answer to your question. Okay. More questions? Is there anything else interesting in 3D? I actually wrote an article which has just been sent off to this teacher's magazine about 3D. So let's see if I can. Yes, yes, yes.
How would you produce your first created sphere, and then the square inside it is about outside?
Okay, and we're talking 3D, yes? So first create a sphere. That's easy enough. Yeah. Okay. And then you want a circumscribed cube around that. Because the cube is defined from the corners, right, which are not on the sphere. I would have to decide that the cube would be parallel to the axis. and I would then I would probably actually yeah, I would probably first return to 2D by intersecting the sphere with the XY plane so I can see it. I would then create a perpendicular line perpendicular to the x-axis through point B. Find the other intersection up here between the circle and the y-axis and the circle and the x-axis. Make another couple of perpendicular lines. And then intersect those to get the corners. Which are in the midpoints. You're a nasty person. So I've got to go up and do roughly the same thing, yes? So we've got this. Yeah, we could. Well, I'm thinking the point B, which defines the radius of the circle. I'm thinking I'll say r equals the x coordinate of point B, so I get that as a number, and then I'll put either I put a plane, yeah, perpendicular plane and on there. So okay, so let's do that. We have a plane which is z equals r, yes? And I guess we want z equals minus r as well. And I guess we might as well do the other ones. Y equals r, y equals minus r, x equals r, oops, capital R, and x equals minus r. Oh, that's interesting. It made lines from that rather than planes. Do I have to be here to do the planes? X equals to r. Yes, I was in the wrong window. X equals minus r. Y equals r. Y equals minus r. Okay, so I've boxed it in, and now what remains is to find the corners. So you need to, and unfortunately I've asked for a command which says intersect plane, plane, plane to get the point, because that doesn't exist yet. I have to intersect this plane and that plane to get the line, and then that plane and that plane to get that line, and then I can intersect that line and that line to get the point. I can then From creating a cube, you need 2 points on the plane. Okay, so if I click on that point and that point, which is the wrong point, then I'm done to this plane. Did it do anything? Click on plane optional and then to no cube there. Plane optional then 2 points, okay. Point. Point. Okay. So you need 2 points and then possibly a plane to define. It's the order of the points. So you get the wrong side, you full set, and you do it the other way. Let's try that one. That one. Let's try that one. Okay, that makes something. Well, so that's okay. So that's the principle. You could use the planes, and then yeah, we could have used the coordinates. That would have been perhaps my choice to do that. Some coordinates as you choose. Yeah, it's now bugging. But I try to select point B and it only stays selected. It does this. Then you've got to shut it down. Possibly save first, but
what I noticed in my Mac is that a couple of versions ago, every time I did something really I could save the first time, but then I couldn't save it the second time.
okay.
It was a little bit annoying.
Yes. Yes. Yeah. When you get too many things in the 3D window, it just bugs out, and you need to save, shut it down, and restart it. Sometimes just shutting down the 3D window and opening the 3D window again will solve things. But it's like CAS in version 4.0. Yeah, if you have too many things, too many points, things like that. Okay, so that was a little bit about 3D. Intersections, planes. There are a couple of commands, like icosahedron, and you put in 2 points. And I didn't like that. Oh no, I shouldn't bother about spaces. But sometimes it wants a direction, which is the same as a plane. Yeah. But, well, as you see, it's a little buggy still. Well, it then has the edge length, and it just creates it out of that. Let's have 2 points. octahedron AB z equals 0. I can drag those, changes the size. But as you see, it's being GeoGebra, it creates all these points and segments and triangles. So just one icosahedron is a lot of objects. And if you try to intersect it with something else, it's going to be difficult. Right? More questions? One thing I like about 3D is that you can do the equation system in 3D. So if you've got an equation system like 3x plus 2y plus z equals 10, that's a plane. And then x minus y minus z equals 10 is another plane, and minus 2x minus 3y plus 2z equals 10 again. And this looks very difficult to see, but again, rotating it will give you some idea of what's going on. You can see the points here where they intersect. So now you intersect two surfaces and you get a line, and you intersect two other surfaces, you get another line, and you can do the other two as well to get the third line. And then you intersect two of those lines. Sorry, not that one. Intersect lines to get the point. And here's the answer. So that's nice, and it ties in well with showing the same thing in 2D. And
Is it only linear equation with that can you write z is x times y?
yeah, you can do that. You then, what you do then is actually create a function, but you will then have difficulties finding the intersections. So you can see where it is, but you can't calculate where it is. But let's say z equals 0.1 times x times y. Okay.
I define function f,
Yeah,
x and y.
apparently you have to do that.
So that's not
Yeah. It would have been nice if it understood that. But obviously it doesn't. But there is the surface. That's a saddle, classical saddle point. And if you have...
4.5 make the slider, then you can make it
I'll just see what happens if we have 2x plus y plus z equals 10 as a plane, and then try to intersect the multivariable function with the plane. Oh no, it doesn't work. can still see from just looking at it what's going on there, but you can't actually calculate that yet. We shall see. Yeah. Okay. More questions? 42. You know where I got that from. Okay. If you don't have any questions, let me show you some other stuff. Starters, let's get rid of some noise. So let's restrict ourselves to 2D for a while. And have you spent any time with the probability calculator? This is an yeah, it's also moved here. So this, you can always find it here now. But sometimes I find that it's gone out of this menu.
I don't have this.
Oh, right, okay. No, true.
But I have this one.
Yeah, it shifts around a little bit.
Yeah, I know.
Anyway, the probability calculator is all again in a window that you can stick with the rest, but this one I quite prefer to have it on its own, and you can maximize it and just use it as a program of its own. And it's really nice because it gives you the power of calculating these things very, very easily. It used to be that if you had a question in statistics, the answer would always have something to do with exactly 1 or exactly 2 standard deviations. And now you can give students problems that don't lock it in because it's so simple to calculate it. All you have to do is drag the sliders or change the numbers. So let's say we measure fish and the average length is something like 35 centimeters with a standard deviation of 4.5 centimeters. And you want to know what is the probability of finding something which is larger than 50 centimeters. Well, first of all, from the start it's set out to be an interval between two numbers, and this can be changed by clicking on these buttons down here. So if you want to find a right-sided distribution, you click that one and just punch in 50 centimeters, and you see that it's almost no probability of finding fish that large. If you'd restricted yourselves to 45 centimeters, then it would have been a 1.3% chance. But let's say that you want to guarantee people, or you want to say that come and fish in my river. At least 10% of you will get fish larger than what? Well, you push in 10% here, 0.1. I will solve it backwards for you, larger than 40. So this is the easiest tool I've ever seen to calculate normal probabilities. And give it to the students and they can suddenly solve problems which are so hard that we didn't put them in the book. It removes the restrictions that the book gives you. Yes, 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 I hope so. I believe it is. And it doesn't do only normal distributions. So in school, we normally have the normal distribution, but we also have binomial distributions, which are when you have choices like, well, let's roll a die and see how many times we get a 6. Okay, let's do a book example. You roll 3 die. We're watching at when we get 6s. Okay, so the probability is 1/6. What is the probability of getting at least 2 6s? Well, it seems to be 7.4%. Okay, now you could have done that by drawing a tree diagram and get the same results. But if you ask, let's roll 20 dice, what's the probability of getting all 6s? You can do that. But if you ask, what's the probability of doing 14 or more 6s? You can't really do that. That was very low, but let's say 7 or something. 3.7%. I mean, if you want to do that by hand, it's really difficult, but it's possible here, and it's very simple. But you have to teach the students the techniques. You have to teach them when to use the binomial distribution, when to use the normal distribution, when to use the hypergeometric distribution, and what does N and P and capital P mean in this case.
Actually, it should be.
Yeah, exactly. Yeah, I mean, it's still useful to see what happens for small cases with pens and paper, but now you have the tools to do real problems. The hypergeometric distribution is when you pick beads out of a bag and put them back again each time, so the probability never changes. So in this case we've got 60 beads, 10 of them are red, and we pull out 20. What is the probability that more than 6 are red? 5.85%. And again, you could have done this for certain low numbers, like what's the probability that 2 are red? And you then do a 2-step tree diagram again. But for 6, it's a little more difficult. If you want to, you can overlay a normal distribution which has the same mean and standard deviation as this particular distribution for comparison. You can copy this to the graphics view, and then when you go to the graphics view you get the diagram there. If you want to do several things and compare them, for instance, you can copy both into the view.
Does the list that it's in there, does it have it's just created from those that they are not dynamic. If you change these,
I can't actually edit those numbers, but I can select in the list what I'm interested in. Or I can drag the sliders, or I can change the numbers.
I have a problem
Yeah.
about if you have a sampling spreadsheet, this
start off by having a new file, spreadsheet, put some numbers in, just one column,
Yeah.
34, 45, 56, 47, 49, 38, 38, 45, 42, 41, 39, 40.
Now choose those and put two. No, I mean the tool up there, the one, the analysis tool. That
One variable analysis.
analysis. And now if you see the, you look at the x-axis,
Yeah.
it starts from 34.
Yes.
What does it mean? It goes from 34 to 30, a little bit over 30. But it's not numbers.
No.
You have to do it by your hand.
Yeah. You open up this thing, and this is a histogram, so it fills up bins. And the bins are automatic unless we want to set them manually. And you say, I have a start at a certain position and the width is that.
3.5.
So you want 33.5 and you want a width of
Maybe
1.
Because now it's kind of right.
Yeah. Yeah.
But the original version is.
Yeah. What it does is something like it takes the maximum minus the minimum, adds a little bit to the axis and divides it into like 10 classes and hopes that you're happy.
Never.
No. No.
I think I once even.
Yeah, it should be another algorithm to do with the number here, for instance, or the absolute difference of them, or something like that.
So what's nowadays the frequency table? It creates down there show frequency table. So does it show it properly now? Yes. And it takes frequencies from.
Yeah, and these are the classes that you've set manually.
But I like this tool also.
Yeah, you can have the relative frequency if you want to, or normalized frequency.
And it will show also the up there with the signal.
Yeah. This is quite nice because it also shows, yeah, if yeah, n is 12, that's the number of data. Oh, that's the quartiles. It's the median of the lower half, and the Q3 is the median of the upper half. They're used to make box and whisker diagrams. I click the sigma to get this. Yeah, and here you can get a box plot of the data as well. Or you can get bar charts, stem and leaf.
How did you translate the stem leaf in Sweden?
Stam och bladdiagram. I tror it doesn't really exist in Sweden. But, yeah. Yeah, and same thing there, but if we have another column of data, say 12, 13, 14, 15, 16, 17, 16, 15, 13, 12, 11, 12. And you do the two variable regression analysis. That's interesting.
You need to restart, I think.
No?
For me, it happens when I have made some analysis with one
I-
variable, and then I need to restart it.
Yeah. It's probably because something else was open. Let's start another instance. Let's see if we can do something. Just have some numbers. 1, 2, 3, 4, 5, 6. 6, 5, 3, 2, 1. No. That works fine. So this is to before you actually do the regression, you can try the regressions and see, does that work? Yeah, roughly. Does this work? Yeah, maybe. Does this work? Yeah, maybe. Maybe fifth degree would work better. Etc. Can't do that. Can't do that because I've got a 0 value somewhere. Oh, sine works fine. And if you also look at the sigma there, there's something called SSE, which is the sum of the square errors. So if you draw a line, a vertical line from the point to the function, that is known as the error. And it can be positive or negative, depending on whether the point is above or below the line. So you square it to get rid of the minus sign, and then you sum that. It's the same procedure as when you calculate the standard deviation, except you don't then take an average and take the root of it, because there's no need. You just stop there. We sum the square of the errors. And that is an excellent estimate of the fit. So for this, I get 0.2. For the linear, I get 0.4. So the trig is better. It's not surprising. It's got like 4 or 5 parameters instead of 2. So the log is 1.2. It's clearly worse. The second, the polynomial is, well, that's perfect, because it's fifth degree polynomial. There's too many parameters. But the third degree will get me the same as 5.2. Second degree is slightly worse. So you can judge which fit is best if you don't have a theory which tells you what fit it should be, and then you've got to stick with that, or else you're on very loose ice. Yeah, so these are nice tools that are like built in, but little known, I think. There's also the function inspector. If we have a function 0.5 x squared, to get the nice little square sign, you press Alt 2. And you don't, exactly, plus 2x minus 1. And you get something like that. If you then go into the function inspector and select that function, you get a nice little tool that tells you things like minimum and maximum value in the interval. It adds things. You can change around the interval by dragging these points. It can show points. So here's one point, but I can add there's a list of points, and I can change the step size if I want to, and drag them around and see the table. There's a little thing down here which is a list, or just one, and you can add the lines or not have the lines, and you can have the slope or not have the slope. And you can also add the derivative of the function to see the numeric value of the derivative there and see what happens. It doesn't show that graphically, but shows you in the table form. So it's a nice little thing. It's got a root at 0.45. It's got an integral, area, mean, difference between integral and area, etc. So another little tool. And if you want to make it stick, you copy it. You copy something to the spreadsheet, and you get these values in the spreadsheet for later. So that's the extra, like, hidden tools, toolboxes. Are you okay with this?
Yes,
You said
it's very nice.
okay.
I'm a beginner. I
Yeah.
have like many ideas how to.
Good, excellent.
And it's like the same functions like in other programs as well. Like
Yes, I mean most mathematic software have similar syntax. You have lists with curly braces and commas. You have coordinates with parentheses and commas, etc. So once you've got over the barrier that yes, since a point is normally written with parentheses, I can actually enter that into the computer and get a point, you've got half of it already. Okay. There's an odd little function here called freehand shape, and the pen just scribbles something, so you can say hi, or you can like circle something. Ooh, look here. Not perhaps very useful, but still. But this thing is quite useful. In theory, you can draw things like this. You can draw ellipses. Sometimes, if you're very clever, you can draw a circle. Triangles are difficult. Yes, and you have to have all three sides very linear. There. Yes. Yeah, it's I don't find that at all useful. What I do find useful is the fact that if I do something that could be a function, it makes a function. And that means that you can take your kids and do things like, okay, draw a function of your mood today. Well, okay, it wasn't very good to begin with, but it quickly got better after breakfast. But then we had math, and then we have PE, and then we go home. And sometimes it works. Yeah.
This moment where there was
Yeah. If you don't keep going forward, then you have a problem. And this is a proper function, in the sense that you can calculate the value g of 4 like that.
Does it make analyze this function?
Well, you can do the integral. Well, let's have a look. But let's just say first that you can do the integral of f from 3 to 10, and it will do that, but it will not do the derivative. Doesn't work. Undefined. Why? Because it's small points with line segments, and it doesn't like to, or the developers have decided that it's not very useful to have the derivative for a function that is so frequently discontinuous or not non-derivative.
Can you do projection to get
Well, yes, in a sense, because you can put points on, and then you can do regression from those points. So if you think that, well, this actually looks a bit like a fourth degree polynomial, yeah? So let's do a regression. No, it's in English it's called fit. Fit polynomial list containing A, B, C, D, E, F, G, H, I, J of degree 4. And I can then derive that. Yeah. So you can do almost all things with functions, and
inspector works?
the inspector works. Yeah. Okay. So the function inspector for that function. Yeah. That works fine.
Do you know what that fit is called?
Yes, they're called regression, and if you start typing regre, you get the list of all of them. Yeah, sometimes if you type the English, it does it. I've actually used this once. Yeah, the freehand function, and I will show you here. This is a freehand function. What does it say? Well, this is all about a climate scenario. It's called the ice ball or something like that. And the idea is that there is such a thing as the albedo, which is the reflective power of an object in space. If the albedo is 1, then the planet looks like a mirror. It reflects everything. If the albedo is 0, it's totally dark. It absorbs all the energy. If Earth was iced over, it would be very white. So the albedo would be approximately 80%, 0.8. So at the temperature on the x-axis shows you that for low temperatures you get an albedo of approximately 8%. However, if Earth was extremely hot, we would have clouds all the time. Clouds are not quite as reflective as ice, but they come up to 50% if we are cloud over all the time. For fair weather, we have an albedo of about 20% because we've got dark oceans and dark land. Okay. There is no function to describe this. So you describe it by drawing a freehand function, like this. And then there's a feedback loop, because the sun always shines with the same amount of power towards the Earth. So, and the Earth then accepts that power depending on how much albedo it has. If the albedo is 80%, only 20% is coming in. From that input, you have a balance. It's got to radiate as much as it takes in, and that determines the average temperature of the Earth. However, the average temperature of the Earth, which you've now calculated, may be another temperature than what you had. So it gives you a new albedo, which gives you a new temperature, which gives you a new albedo, which gives you a new temperature, etc. So this is done here in a recursive way. And the green, the red is the starting point. Starting point is 24 degrees and an albedo of 26%. The green thing is the long-term behavior. It's the Yambik, it's the equilibrium. Yeah, it's the long-term behavior. And what happens is that if you change this, the other one changes as well, and suddenly, see, if you go here, you suddenly get a jump, and because you run along this line, and you get an escalation where the albedo gets higher, you get less energy in, so it gets colder, so the albedo gets higher again, and you have a runaway effect, which ends up in the ice being in Earth being iced over. And this is a well-known training scenario for climatologists. It doesn't tell you anything about Earth really, because it assumes that Earth is a homogeneous globe with no winds, no oceans, no nothing. So it's not a realistic scenario, but what it does show is there are such things as runaway effects. And they come from feedback loops, and there are lots of feedback loops in the climate. So
one way they are kind of explaining why we have those times we have lots of ice.
yeah, ice age.
Ice ages.
Mm.
Why do they stop?
Well, more feedback loops.
Yeah.
We don't know.
Yeah.
We haven't got a clue. But you can also note that if I try to go the other way, there is that one stops at 50. Let's make it go to 100. Yeah, it must have changed something there. But the same thing doesn't happen the other way, and I think that's because the slope here is lower, so you don't get the runaway, whereas here the derivative is more than 1 or minus 1, which means that if you've seen these spider web things, they can either converge or diverge depending on the slope of the function. So that was just a dip into climatology to show you that yes, there is a possible use for freehand functions, because sometimes you get phenomenon described in words, but you don't have a function, and you can then actually work with it. Right. What else do you want to know? Do you know how to make all the signs here? When you click in the input bar, you have the little alpha sign to the right, and you can select all these things. But you can also just type Alt A or Alt B, Alt G. Most things you can well, I don't use iPads. iPads are not production tools. They are consumer tools. So you look at something that someone's already made, and you play with that, and you pull the sliders and learn something, but you don't make the construction on them. If you, what courses are you doing? Are you upper secondary, lower and upper? Are you doing courses with differential equations, complex numbers? Sorry?
My next course will be a probability math. It will be good to show the probabilities.
Yeah.
What else can you do with the probabilities? Do you have something?
What else can I do with probabilities?
Introduce or something, probability or something.
Yeah. Well, there is the spreadsheet. View spreadsheet, and I find it useful to click on the little triangle to show the tools, and then click F of X, because then you get the bar. If I type a command here, I get the options, but if I try and type a command in the actual cell, I don't. So I find it useful to type in there. And there are some random numbers.
What is it in Swedish? I have the Swedish word.
You have the Swedish slump, tal mellan. So you can have random between to produce a typical die. Random between 1 and 6 produces a random number between 1 and 6, and you can easily have many of that. And just as in Excel, if you hit F9, it recalculates, and if you press Control R, it recalculates as well. So that's a way of getting random data if you want. And then of course you can analyze those data by with these tools like one variable analysis. You may also want to look at so Control R changes that. You may also want to look at what's already been done. I'm now signed in in the forum, and you have a user.
Yes.
Yeah. So then you can go and look at GeoGebraTube and try and find some statistics. Empty statistics, normal distribution, degrees of freedom, random walk 2D, statistics calculator, practicing. Well, some people have done something, so you could go to GeoGebraTube and search and see what they've done. Saves inventing the wheel again.
In all of those, you were able to download the actual GeoGebra file.
Yes, if I open this one from within, I must have clicked something else. Yeah, I clicked his name. If I can either view it or I can edit it. So if I click edit, it opens in here. If I go to some place, you can always download it from here. And then you have to accept the terms, and you can download the file.
Are there like exercises as well, like that you can like have for the students?
Well, that would depend on whether anyone has done anything like that. It's only user-driven, so there's no official stuff. But like Salt said in the plenary, in the first plenary, Hungary is looking through these 100,000 to produce, I think, 1,200 really good ones to be used in school. Maybe they have something. Send them an email. Give me all you have on statistics now.
Because I find that's one of the thing, there's so much stuff out there, and until you're a confident user, it's very difficult to pick.
Yeah, it's a bit like moving around in a storm. Yeah. You have to be able, if you want to go out here, you need to spend some time to find it and see what it does, and is this useful for me, and if it is useful for me, perhaps download it, translate 2 or 3 things, make a change because you want to show something else as well, etc. And yeah, it takes a little while.
Because usually you don't have that time exactly
No.
evening before, and you need something for the next morning.
Yeah. No, it's. I think it's better if you spend a little time to look at what you're going to do in 2 months' time, and see if you can do something for that. Otherwise, I would stick with on the spot and create yourself. I just go up and say, right, let's do something, and whoops, something happened here. Oh well, let's try another thing. Lose a bit of control.
Because what I'm trying to get good at, which I'm not good at yet at all, is creating these things where they actually fill boxes or choose the right one. Like, say for instance,
Okay.
like what I would love to do is, for instance, you get, say, 3 different photographs, and we get one equation, and they have to click on the graph that match the equation, for instance, something like that.
Okay, let's see if we can do something. Okay, so we've got 4 options there. and you have a question, so you make a text box saying which graph is y equals to x minus 1. Okay. And perhaps we show their labels. And then what we want is alternatives, which are checkboxes. So you can have. Yeah. Well, what we'll do is we'll make texts saying nope, try again, and another one saying yeah, you did it, and another one saying oh no, sorry, but this wasn't it. And the final one saying well, and then we have a checkbox, and we want it there, and the caption is A, and we want to show text 1, and then we have a text box which is B, and we want to show text 3, I think, and we have a text box which is C, which is the right one, yeah? So that should have text 2 in it. And the checkbox D with text 4 in it. And obviously you want to line them up and do things nicely, but oh, that was text 5 actually, so we screwed up.
Yeah, I get you.
Yeah, okay, so oh no, sorry, but this wasn't it. Nope, try again. Yeah, you did it.
Then it would be possible to put random numbers in the line.
Yeah. You see, if you don't have these lines, then first of all we create some numbers like A equals random between -3 and 3, perhaps. This will produce whole numbers. If you want half numbers, then divide by 2 and make them from like -6 to 6. Okay. So I now get 2.5 and recalculate that number of times. And another number B. Control R for recalculate, or F9. And you just, if you press, you can get, if you press arrow down or up, you get the numbers, you get the previous commands. That helps. So I've now got two numbers, and I now just change this to AX. Oops. AX plus B or something. I can remove that one. And so Control R. Yeah. Yeah, whichever. So that's a random line. You then want to check an answer. So we have answer 0, and perhaps we have a new text saying what is the slope and I want an input box which is called well, slope or guess, I guess, and we connect it to answer, and then we have it connects to the value of answer, and it always has a value. So yeah, yeah. And I now have a text called correct, which I can make a little larger, and I can make it green or something. And I only want to show it when the answer is the same as the number A. So I go into the object properties of that text. On the advanced tab, there is the condition to show object. And I say answer should be equal to double equal signs A. And it changes that to the equal sign question mark symbol. And as you see, it's gone. But if I now put minus 1.5, it's correct. And then you want an easy way to get a new line, so you may want to have a button saying new line, and I think it's called, is it? It's not update construction. Update construction, just like that. The button tells them to get a new thing. So what's the slope of that? Well, it's 0.5, correct, new line. What's the slope of that, etc. As you see, texts are not normally fixed in the window. You need to give them absolute position on screen to do that. And if you want the kids to not mess things up, you may want to fix the object as well. Well, those that can be fixed. It means that you can't change it until you unfix it. So, like, you can't edit it. until you unfix it. So you've now done an automatic testing thing for finding the slopes. And once you've done that once, it's quite easy to do another one, changing it to what's the intersection with the y-axis, or do quadratic functions, find A, find B, find C, etc. So that's nice. You may see that there's something called Boolean values here. A Boolean value can be true or false, and the graphical representation of that is the checkbox. It's either checked or not checked. So just as a slider is a graphical representation of a number, the checkbox is the graphical representation of a Boolean value, a true-false value. And these values can be used in like conditional visibility
If you write
statements.
E and F, does it create a new?
Yeah. Well, it creates a new Boolean value. So E and, shortcut is double and, F. Or you can use these signs. That's and that's or, and that's not. E and F will create a new one, which is not visible from the start, but you can make it. No, you can't make it visible because it's automatically calculated, so you can't set it. The checkboxes are for those that are free objects.
So you can't make a checkbox like name cop equals.
No.
Something.
Oh, I can only make a checkbox if it's free.
Yeah.
It's the same with sliders.
Yeah.
If you have a number which is controlled by other numbers, then it disappears if you have it as a slider.
Yeah.
I've done this before. You create 3 sliders to define the size of a box, and you draw the box, and then you say, well, C is actually, because of the area being constant, we can calculate C as a function of A and B, and you enter that, C equals blah blah blah, and you hit enter and C disappears because you can't set it. It's automatically set.
Does false equal 0?
No.
So they are
This is, I don't know, they've made a choice, but it's pedagogical perhaps, but it's annoying. It would be useful, but yeah, no, it doesn't work. You've got to say if this equals 0, then etc. Yeah. Or the symbol is the that one. But if you want a shortcut, it's D vertical bar E. So two vertical bars for or, 2 ampersands for and. And as I was saying, there are a lot of things you can do with shortcuts. Like for instance, you can say square root is a function. Square root of 4 is 2. But you can also type Alt R and get the root sign. It's a bit more obvious. You may need to enclose stuff in brackets. If you let's have a new one.
Where do you find is there a page in some manual where all the
Yeah, there is a page in the manual which shows you every single one. If you Google algebra keyboard shortcuts, you find the correct page. And there are a few. But typically, if you use Alt, like Alt D, you get a Greek letter or a special character of some sort. If you use Control Shift something, it typically opens a window. Control Shift S, spreadsheet, Control Shift K, CAS, Control Shift 1, 2, 3, drawing area 1, 2, 3D, etc. Two specials. If you have like if you're into complex numbers, you can type 4 plus 5i to produce a complex number. But suppose you've already done some constructions and I has been assigned as a variable, then it doesn't work. So you then have to type 3 plus 2 alt I to produce the imaginary constant. Same with the Euler E 2.718. If you just punch it in, y equals 2 times e to x, it does it nicely. But if you have something and e is already defined to be a number or a constant or something, you have to type alt e to get the Euler constant. I'm just dragging, but you know this, just dragging it will replace x with x minus something and other plus or minus. So it's translation of functions is very easy to show. What else can I do for you? More questions? The general way of learning any software is use all the menu options, click every single button. Play with it in your bed, on the bus, going home from work.
They spoke to the cast view. There was some bugs in some versions. So there was the function tool was over there in some versions.
The function tool was over there.
Yeah, up there. Function analyzer.
Yes, function analyzer.
Oh, the function inspector.
Yeah.
Okay.
No, I have probability calculator.
Okay. So if I cast view.
You want the cast view and the function inspector.
Well, I mean, if you are in the click on the cast view.
Yeah, I'm here.
Then in some versions of our GeoGebra we have the function analyzer inspector in there. You don't have it, but you.
No,
or you have not.
probability
You have the
calculator.
proper filter.
Yeah, it's probability calculator has been going on and off from that menu.
Yeah, but I don't have it in graphic view anymore, I think, right now. So changing out.
Oh, you mean in the bar, or
In the buttons.
in the buttons?
If I'm in SAS, then I have it here. And if I'm in graphic view, I don't have it here.
And I had some days ago I had the function
Changing
inspector.
out they're changing because I'm with everything changing
You
and I have this view
she has the function in the thing.
In the test,
Yeah.
in the test. Depends for every person.
And
I
think
have the Swedish version.
it's
Yeah. Well.
It's just for me.
you should write the book. I don't write.
I'll ask them to clarify. Doesn't matter where it is as long as it's in one place. Yeah, strange. Huh. I've actually got 521. So maybe that was an experiment for 520.
It's kind of annoying when you.
Yeah, they do these things. They play around a little bit. There was a period with cast when everything was going all over the place.
My workshop, the math teachers in Denmark, when I prepared my thing 2 days before, and then I loaded the new one.
Frozen on this program.
Yeah. So how familiar are you with CAS?
You can show it.
There are a couple of things you might want to know, but let's start simple. Let's say we have an equation, 3x plus 5 equals 2 minus 7x. You can type in the equation and then you click the equals, and it solves it. No, it didn't. You need in CAS you need. No.
You just click x equals.
Oh, there, of course, sorry. Of course. And you get in symbolic form. Now you can get stuff in symbolic form in the graphics window. That is quite useful to know, actually. If I have like two lines intersecting each other, there is a command called rational text. No. Right, I've got to switch to Swedish. I'm finding the tool that gives you a rational text. This will be just a matter of seconds. Swedish. Rationella taltext in Swedish. And you get the coordinates in rational form for the point. And if I now change back to language, English, I can see what that is. Fraction text in English. Fraction text. And if you have, same thing, if you have, let's say, y equals x squared, and you have y equals 3, and we find an intersection point there, then there's a command called surd text, which will give you a text label which will show the coordinates in with roots. So you can do a little bit of CAS in the graphics window.
How could I get the -3 tenth out of the list x equals something?
Okay, how do I get that? You extract an element from a list with the command element.
The rational text.
The
It's just the text now.
Yes, it's just a text. You can't use it for anything. It's just a text. Element, list. So what's the name of the list? And this is where the CAS comes in. In all these CAS systems, GeoGebra, whatever, you can always refer to the previous boxes somehow. In GeoGebra, you refer to them by hash. And either hash is the previous one, or #1 is line 1. So I could, and then position, well, there's only one list, so it's one element, so position 1, and that gives me that. And then, if you want the -3/10, there's a command called right side of equation hash. And you can then do things like assigning a, and then you can't put just equals, you assign with colon equals hash. I don't know where that E came from, but probably I said A, yeah? And A was already defined as a line, so it had to choose another letter. It does this. You've got to be careful. So picking things out of lists, picking things from the side of equations to work on with them, etc. I'll just show you what I did. Norwegian problem. Do you remember that? No. There was a problem in CAS which Torrespen said, oh, the students didn't have any idea how to do this. It took me 2 tries, but I did it. No, I don't. And the question was, you had second degree function and slope, and you find this area, and it is only dependent on the distance between the points. Prove that. So in CAS, I define a function ax2 plus bx plus c in general terms. So it's nothing showing because you can't show it because you don't know what a, b, and c are. So we can just ignore that. We define q as being p plus delta, where delta is the difference. So, okay, fine. It now knows p and delta and q. We define the point P as having x coordinate P, y coordinate f of P, and same with Q, and it calculates these things in terms of the known basic variables. I then calculate a dy and a dx. I don't know why it's not showing a dx, which is the same as delta, and the k, which is the slope, and I then use the 1-point formula to formulate the equation of the line, which is the slope times x minus the x value plus the function value. And so there's a line, which is this. It's got x's here and a couple of terms without x's, so it is a slope. And I integrate between function f and g from p and q, and it's not only it's dependent only on delta and a. This is very boring, I find it. It's strong, it is a proof, but as all proofs, they are boring. So I made one without cats as well. So I defined a function with sliders a, b, and c. I defined numbers, a number delta and a number p, and I calculated the number q, which is p plus delta. I then produced the points p and q. I made the line and I calculated the integral, and I can see what happens. And that's something that we could have just thought about ourselves. This is slightly more difficult, but yeah, it could possibly be worked out. But it is dependent on that, and it's not at all obvious that this is the same. But it is. But if you change delta, then obviously something happens. But I think the strongest way of presenting it is to show both. This is what happens, this is the proof.
And it doesn't take time either to show it, because they're also quickly, so you don't
Yeah.
waste any time by
It
showing it
took
at
me
the
half
same
an hour
time.
in bed to work out the proof. But
Yes. But I think this one, like to show it then for the pupils.
Yes.
Makes it not waste of time in the classroom. Like
No. This is more like a demonstration thing.
Yes.
Here is a statement. First investigate it. Oh, this is what happens. But can we prove it? Well, let's go to class and see what happens. Yeah. Of course, I mean, even in class, this is just production, creating the thing. This is a little obscure. We calculate it and it turns out to be. Wow, we proved it. Well, no, GeoGebra proved it. It's still unclear to us. So there's perhaps a couple of steps in between that might want to be checked. But yeah, but this is like an automatic proving system.
But then when the students are allowed to use like the class function in their exams,
Obviously, they need to show this. I mean, obviously, you need to show this to show the workflow of how to work it. Originally, I made a try when I remember what I did. I started with two functions, a general line and a general quadratic. I intersected them and I pulled out their coordinates. But then I couldn't, it got too messy and GeoGebra couldn't do the calculation in the end. So then I got to think, well, perhaps it's easier for GeoGebra to do it if I have a variable from the start which is showing exactly what I want to do. This is not obvious to start with. I think my time is over by a quarter or so, so I will stop this